In this project, I will demonstrate how to use user switch present on FPB-RA0E1 board. Take help from this quick start guide document for board layout and pin diagram. One user switch is present on this board which is connected to P200. Open ESK Studio, then click on New, then select Renaissance C++ project, then click on Renaissance RA project. You can give name to your project here. I am naming this project as GPIO input example. After giving name, click on this next button, then choose FPB-RA0E1 board. You can use this drop down menu and select FPB-RA0E1 board. Click on next, then select executable and no autos option for this project. Click on next and choose bare metal minimal project. After selecting bare metal minimal, click on finish. ESK Studio will initialize default IO stack for FPV RA0E1 board. We need to modify default setting for P200 to use as GPIO input pin. In pin tab, click on P2, then click on P200. By default, it's configured as interrupt pin. We need to modify some settings to use this pin as GPIO input. Scroll down in Pin tab to find Interrupt IRQ. Disable interrupt for P200. Go to P200 again and select Peripheral Mode as GPIO input. Then click on Generate Project Contents. In Project Explorer tab, open Source folder, then open halentry.c file. In this project, we will also utilize RTT by Sagar. Go to download section, then click on JLink. You can select JLink according to your operating system. I am using Windows 64-bit, so I am selecting 64-bit installer for Windows. Sagar also provide different embedded tools for programming or debugging the hardware. In product or download section, you can find different tools or products. System view is one of the most critical one when debugging the FreeRTOS based solution. System view highlights CPU usage between different tasks. It shows in a graphical way when the CPU was idle or performing a task or which timer were active. It is very critical when debugging FreeRTOS based or real-time constraint project. Download and install JLink software. By default, it will be installed in program files under the name Sagar. In Sagar folder, there will be a folder name with current JLink version. Open this folder, then open samples folder. In sample folder, open RTT folder. Now extract this zip file here. Now open RTT folder. We need to add these three source files in our project. Now from config folder, we need to add this config file in our project. In ESK Studio, right click on SRC folder, then click on new, then click on folder. You can give name to this folder RTT. In extracted folder, you will see a RTT folder. Go in that folder and copy these three files. Paste this file in our project under RTT folder. We also need to copy this config file from here in our project under RTT folder. Right click on SRC, then select new, then select header file and give name to this file as commonutil.h. Then click on Finish. In commonutil.h header file, we will paste some data related to RTT configuration. I will attach commonutil.h file you can copy and paste in your project. Include commonutil.h file in hall_entry.c file. User application will start from hall entry function. You can write your user application here. I am creating a counter variable. This counter variable will increment when the user switch is pressed. Now I am defining BSPIO level variable. This variable will store the GPIO state. I will create a while one loop here. You can take help from this developer assistant tab. This developer assistant tab will have API call related to stack we configured in FSP configuration menu. Drag and drop this GPIO pin read function in hall_entry.c file. To check status of this function call, we will utilize fsp underscore err underscore t variable. This variable will store either error or success according to this function code. We can use assert function to make sure pin read function was successful. We need to give the name of the pin we want to read. By default, SW name was given to user switch. After that, we need to send the address of the pin state variable. Now we will check when the user press the user switch. If GPIO state goes to low, that means the user has pressed the switch. You can press Ctrl plus space bar to get suggestions. If user switch is pressed, then I will increment this counter variable. Then I will use app print function to print this button state to RTT terminal. This function will print formatted string. We can read this formatted string in our workstation using J-Link software. When the user switch is pressed, counter will increment and it will send data to J-Link software using RTT. Now I will use RBSP software delay to create delay in our program. You can press Ctrl plus spacebar to get suggestions related to functions or variable defined in FSP. I will create a 1 second delay. After 1 second, it will read GPIO pin. If GPIO pin is low, then counter is incremented, else the counter remain as it is. Click on the project name, then click on this hammer icon to build this project. Right click on project name, then select debug as, then select run as GDB hardware debugging. Click on this resume button, then again click on this resume button. Open JLink RTT client software. Counter variable will be printed here. When user switch is pressed, counter variable will start to increment. When user switch is released, counter variable will stop incrementing. It will start to increment again when user switch is pressed again. Now I will show you some of the ESK Studio feature for debugging your project. I have added some comments to explain the program further. When the user switch will be pressed, LED1 will turn off. Otherwise, LED1 will be turned on. Now build your project again and start a debugging session. You can change your IDE perspective from here. Now I will add some breakpoint to stop execution of the program on particular line. Open hallentry.c file and double click on the line you want to stop execution at. Now click on window, then click on show view. Here you can find different windows to debug your program. In expression windows, you can check the live value of a variable. In breakpoint window, you can see all the breakpoints you have created in your debugging session. As you can see here, as soon as I click on resume button, program execution is stopped at the breakpoint I have created earlier. Now I will test my program on FPB board. As I press user switch, LED 1 will be turned off. As soon as I release user switch, LED 1 will be turned on.